Hey guys, welcome to the beginning of another tutorial series. You may recall a couple years ago I made a series called The Beginner's Guide to Restoring Early Classic Black and White Televisions that focused on the type that used a magnetically deflected picture tube, which was the majority of sets. I also mentioned I'd be doing a companion series on the other type of television that uses electrostatically deflected picture tubes, and that is going to be the focus of this series. In particular, we're going to be restoring this television, and I'll show you a few other types along the way. This is a 1949 Admiral 17T1. It may look like a 19A1, which is a little bit earlier and more common, but this is the later, last generation for Admiral. So in that magnetically deflected series, we did a 4849 Admiral TV. So this was sold at the same time, and it shares a few common elements. So much so that I'm not going to go in as much depth in this series, so I recommend you watch the other series as well, because these both receive the same type of signal over the air. In fact, they use essentially the same tuner and a very similar IF. So I'm not going to repeat myself and talk about what the broadcast signal is and how it's received and the various components of it for audio and video, how it's modulated and all that, because I covered all that in that series. Now, what this series is going to focus on is what the differences are, what's unique about these, what the unique challenges are to restoring these, some of the pitfalls, and let's start out with, why do these even exist? For starters, what is an electrostatically deflected picture tube? Well, that is a type that uses electric fields to deflect the electron beam. So the back end, the electron gun, is essentially the same. We've got a heater, we have a cathode, we have a grid, we have accelerating anode. So it creates and focuses an electron beam and sends it towards the phosphor coated inside of the glass picture tube. But the difference is how they're focused to some extent and deflected. That Admiral set, the magnetically deflected set we used a magnetic focus coil to construct the electron beam and focus it. So there's a big coil of wire around the neck of it, and right past that is a deflection coil which has windings for in horizontal and vertical orientation that uses a magnetic field to move that electron beam up and down and left and right. So magnetically focus it and then magnetically move it around. This uses an electric field to focus it and then electric fields to move it up and down and left and right. There were some magnetically deflected sets that have electrostatic focus. Just to make that clear, there's a little bit of blurring there, combined a couple techniques. But let's draw a dividing line and say one is purely magnetic and this one is purely electrostatic. Now, you may be familiar with this type of picture tube because that's what all the analog oscilloscopes used. Electron gun at the back end, the signal's coming in here, and there are deflection plates inside here, and then it moves the electron beam around the front and paints the image on there. So why did they make TVs with this type of CRT? I don't have a solid answer for you. Some of the big players didn't. RCA didn't. Zenith didn't. Dumont didn't. Admiral did. Motorola did. In fact, they were pretty well known for it. So were the Admiral. Those would be the two most common sets you're going to see out there that use electrostatic CRTs, would be Admiral and Motorola, but plenty of others did too. Sentinel, Airline, Raytheon, Belmont, most of the other makers for that matter. That being said, not all of them made their own chassis. In particular, Teletone, I think, made a chassis, or maybe Wells Gardner did, that was used in a lot of different brands, like Mech, for example, or Automatic. So why did they make them? Well, pre-war sets, electrostatics were more common. And right after the war and the rush to get TVs to the public, and starting in 45, the early kits were all electrostatic. Arguably, it was easier, and they generally cost less, whether they were kits or fully assembled. But the actual picture tube itself is actually more complicated, and there's some issues with it. So this is a 5-inch electrostatic CRT from a scope, probably a 5 BP1. Well, there's a 5 BP4, exactly the same CRT, but it has a different phosphor that makes a black and white image rather than having green phosphor. Well, here is a 5-inch magnetically deflected CRT. So, image size basically the same, but well, what's different about them? Electrostatic is a lot longer. It turns out that it's easier, well, maybe not easier, that's probably not the right term. You have more flexibility with deflecting an electron beam magnetically than you do with electric fields. So here's the trade-off. You're accelerating that electron beam towards the front with high voltage, right? The higher the potential, the brighter the image is going to be. But it's harder to deflect because the electrons are more energetic. They're flying through this faster. They're more energy. Well, that's maybe not the right term, but they're more energetic. So you need more energy to push them around, right? Well, with electric fields, they actually have some squares of metal in there. They go to pins on here. So you've got a couple deflection plates, two on one axis, two on another, and you're going to push that electron beam back and forth with electric fields. Well, the more energy it's got going past these plates, the harder it is to move it, so you need to use more voltage. And I'm talking hundreds of volts when you say running the picture tube on 6, 7, 8, 10,000 volts. It gets to the point where a modest tube circuit can't do it, especially horizontally where you've got higher frequencies. So we're talking about making a sawtooth wave that's linear, that's 500 volts peak to peak, 800 volts peak to peak. You're exceeding what conventional tubes can handle. Maybe a transmitting tube could, but then your costs are going to be crazy. You're going to need elaborate power supply, cooling for it, and your budget's out the window, so why even bother? Or you run it leaner, but then it's not as bright, not as sharply focused, not as well defined, but easier to move around. So typically these run on around 5,000 volts, and the deflection plates 300-400 volts peak to peak. It's kind of the sweet spot trade-off between the two, but they're not as bright as their magnetically deflected cousins. Which means if you wanted to say this is a 5-inch, if you 7-inch, 10-inch, 12-inch, the thing is going to be 2-3 feet long, and that's exactly what they did. In fact, Dumont made a 20 BP4. It's a 20-inch electrostatically deflected CRT. It's very long, and it ran at a relatively low voltage, so I don't think it produced the greatest image. They tinkered with it pre-war, but I don't think it ever went into a production television. It was just in demonstration models. So with all that in mind, the engineers back then balanced the trade-off of screen brightness, sharpness, reasonable deflection voltages, and overall picture tube length, and settled on the 7JP4 that the vast majority of these sets use. It's, well, I happen to have one right here. It's that long. What's that? 17, 18 inches, something like that, with a 7-inch screen. Brightness, well, I've never seen a brand new one. We'll talk a bit more about that later. Could you watch it in a really brightly lit, daylit room? Not really. And its image is pretty small, so you might want to use a magnifier. So again, why do these sets exist? Cost? So Motorola introduced the first really popular one, the VT71, in late '47. It was the first TV to sell for less than 200 bucks. To do it, they did a lot of compromises. These picture tubes were still pretty expensive because they're complicated, because they have to have the deflection plates inside, which makes the gun assembly more complicated than a magnetic set that doesn't need it. However, you don't need a yoke, and they don't use a conventional flybacks. You don't have all that extra copper right on the focus coil, so you're saving some money there. But I think most of the savings came in the rest of the set. They're smaller, so smaller cabinet. You don't have to have a big console. You just have a little cabinet like this. A lot of them Bakelite, or if they were wood, they were pretty basic cabinets, no nonsense. And insides, generally, they didn't have power transformers. They were series strong sets. They usually limited the bandwidth. Instead of being full 4.5, it might be 3 or 2.5 megahertz bandwidth. After all, the really small screen, I don't know, you'd be able to discern a full bandwidth image anyways. And typically, they may have one less IF stage. You only have a tiny speaker, so the audio amp isn't that elaborate. In other words, you reduce tube count, reduce parts count, all the rest of it. I don't think they saved a whole lot in the picture tube per se. It's in everything else that goes around it where they really save the money. Back to size for a moment. Yeah, 7-inch were the vast majority. However, the ones that were directly post-war were 5-inch, the kits in particular. You might be familiar with the Pilot TV, which was the first set to sell for less than 100 bucks. That has a 3-inch CRT, believe it or not, super tiny and really minimal construction quality. Essentially, it has a cardboard cabinet or pressboard cabinet and a really small tube count. But there is a 10-inch electrostatic CRT. I think only Raytheon used it. I believe it's a 10 HP4. And check this out. Now check this out. Now this is a 12-inch electrostatic picture tube. Yes, they do exist. However, this was not made for television. This has a different type of phosphor. This was for radar applications. But the base is the same. I can plug this essentially into this TV. And maybe we'll try that later on. And it should produce an image. I'm going to have to tinker a little bit because the voltages are a little bit different. But look how long this thing is. That's ludicrous. Here it is next to a 7JP4. So, now you don't see that with magnetically deflected sets. If you put a magnetically deflected 7-inch next to a 10-inch next to a 12-inch, yeah, they get longer, but nowhere near this dramatically. And over time they were able to make shorter and shorter picture tubes. They went from 54 degrees to 70 degrees to 90 degrees to 110 degree deflection as they got better at deflecting it and made better yokes. You just can't elude physics with this type of picture tube. Now, back to this guy. Well, I should clarify one thing. This isn't actually a 7JP4. This is a 7JP1. Originally, these were invented for scope and radar applications. So there's P1 phosphor, which is green oscilloscope, and there's P7, which is a special phosphor for radar applications. So this actually existed before they decided to use them in TVs. I think they were developed during the war, and they adopted them, converted them, put a different phosphor on them to use them in TVs. I use this on the workbench for a very good reason. So I mentioned I had never seen a brand new 7JP4. I've had a number of brand new or rebuilt magnetically deflected picture tubes, so I know how bright and sharp those can be. These are really, really hard to come by in any condition. But part of the reason, I believe, is, well, a couple reasons. One, you can't realistically rebuild these. Two, they were used in budget sets, and they're small. So imagine you forked out 200 bucks in 1948 for one of these. Say it stopped working in 1952. Would you really pay money to have like 100 bucks to get a replacement one of these? Or would you drop a couple hundred and get a 21-inch rectangular black and white set, of course you'd trade this in or give it to your kids, and you'd upgrade to a much larger, higher performing set. So I think there was very little aftermarket for replacements for these, so they just don't show up on the secondary market. Why can't you rebuild them realistically? One, different kind of glass. The type using magnetically deflected CRTs, it's not that difficult. I say like I do it every day, but I've seen people do it where they break the vacuum seal. They cut the glass around the neck. They open it up, put a new gun assembly in, weld essentially the glass back together, suck the air out, and reactivate the cathode and all that stuff. These, even if you could cut this open, it's a much more complicated electron gun assembly. We're just seeing a portion here, but down here we have deflection plates. So it's a much more complicated, hence expensive gun assembly. And it has to be positioned correctly because you're relying entirely on the geometry of this gun inside to get the image right on the front. Whereas a magnetic set, it's basically just a gun, and then everything outside is, it's all magnetic fields to move it around and to focus it and all that stuff. And of course it's much bigger, it's got a 14-pin base, so added complexity. And then, yeah, the different kind of glass. I think this is Pyrex versus the flint type glass. I'm not a glass expert, but I know it's a different kind of glass. This is thinner, it's more fragile, harder to work with. That being said, I believe I showed a few years back one that had a seam on it, and I think it was rebuilt. And one or two other guys online have chimed in and said that they were pretty sure they had rebuilt ones as well. So that's the unfortunate dichotomy, I think that's the right term, of these sets. When these were made, these were budget sets. They were the lowest cost sets you could buy, and they're small. So they're popular with collectors and hobbyists and tinkerers because that's small. You could pick one of these up, you could just ship it with some good padding, or you could throw it in the back seat of your car, you could take it with swap meet. Or back then, people just threw them in the closet when they stopped working. So there's a lot of these around, but the picture tubes aren't so hot anymore. So there's another problem with these. All these picture tubes, be they magnetic or electrostatically deflected, can have the phosphor damaged by ions. What are ions? When they evacuate, when they pump the air out of these and seal them off, they never get every last trace of air out of there. So there's going to be a few stray atoms floating around in there, nitrogen, oxygen, what have you. They also get accelerated by the electron gun along with the electrons, and they go flying to the front and they smack into the phosphor and they damage it, and eventually you get a brown spot in the middle. The really early pre-war type sets, oh well, after that many hours of watching it where you get a brown spot, you replace it. It was a new miracle, so they weren't that concerned about it, but pretty shortly afterwards they solved it for magnetically deflected sets with an ion trap, which means they took the electron gun and bent it, and they used an external magnet to make the electrons go to the front, while the ions, which are heavier, would continue and go out the side of the neck and wouldn't hit the phosphor on the front. These don't use ion traps. The ions are continually smacking the phosphor on these. However, you don't get a spot in the middle. Why? Because it turns out that ions are deflected far more readily with electrostatic fields than magnetic fields. So the ions basically move along with the electrons and paint over the whole screen. So you get an even degradation of the phosphor. But it's also spread out over a much larger area, so it's not only spread out, but it takes longer because you don't have a concentration right in the middle. But eventually it does poison the phosphor and they get dimmer and dimmer. It's really hard to test too, because most testers won't do them, but even the ones that do, like the 7JP4, basically everyone I've ever tested is good. They have great emissions, but the actual image quality varies tremendously. In fact, I noted that the Suncor CR70 dropped it from their tube chart. The tube chart that's built into the cover of my picture tube tester doesn't list it. But I found one online, an older copy, that lists a lot of electrostatic CRTs, and they removed these in later editions of the picture tube tester. I think because of that, because you get misleading readings. So it's another unfortunate reality of working on these sets that are supposed to be easy, simple, low cost. Very hard to get replacement picture tubes, and very hard to test them. The only good way to test these is to pop it into a working set and watch it and judge for yourself how good does it look. That kind of stinks. That being said, you could have some fun with these because there are a number of scope CRTs that have compatible bases, like a 3BP1. You might be exceeding the voltage ratings on it, and they weren't exactly intended for this, but generally they work. So this came from a scope. This came from like a radar unit or something like that. You can pop them in here and they'll work. Yeah, but screen size might be only 5 inches or 3 inches, but you can have some fun. You can, if you have a busted up cabinet, you can have it out on display and use a different type of picture tube, different color phosphor, but you can make it work and you can demonstrate it and you can play around with it. Will these ever get rebuilt, reproduced, rephosphored? Never say never, but it seems unlikely. So where am I heading with all this? Well, commonly asked question I see is, what set would you recommend to beginners? And often, traditionally, the answer has been one of these guys, or similar, Motorola set. They're pretty easy to work on, and we'll see why when we pull the chassis. But the downside is the picture tube. They're out there, you ask around, go to swap meets, but just be willing to take one that's a little worn out. So that's just buyer beware. Another thing to be aware of is because these are budget sets, the construction quality might not be so hot, the cabinet might not be that great. These Bakelite cabinets are cool, but they're often damaged or sun faded, scratched up, they're fragile, so there's also a lot of them out there. So I'd say be a little bit choosy. Don't just pounce on the first one you see. I wouldn't pay more than $100, regardless of what the make or model is, unless it's crazy rare or it's in really, really good condition. So your run-of-the-mill Motorola VT71 or Admiral 19A1 that's an untested condition, maybe you're missing a knob or two, $50, less, haggle, something like that. Then there's some other issues we're going to get to, some other expensive parts lurking inside. Let's pull the chassis on this.